Hello out there in remote learning land again. Hope you enjoyed today's do now of finding a whole bunch of different things around you and putting them in density order. Thought you might enjoy that. Anyway, we're going to go a little further into density, talk about how different variables affect it, specifically temperature, pressure, and see how that makes different things behave. All right. I want to start out with a little clip on hot air ballooning. All right, check it out.
Long Island homeowners, if you have a power meter...
Sometimes on a nice, clear day, we can see something special in the sky. A hot air balloon. Have you ever seen one? Have you ever wondered how a hot air balloon works? How does it get up there? And how does it stay up there? Well, it's all about the air. There's nothing special inside the balloon that makes it float. It's just the same air that we're breathing right now. So how does that keep the balloon up there? Well, even though you can't see it, air isn't nothing. It's something. Air is made of matter. Anything that you can touch or feel or that takes up space is made of matter. So air is made of matter, just like water is made of matter. And so are the clothes you're wearing and the food you eat. Even your body is made of matter. So what kind of stuff is matter made of? It's made of tiny things called molecules that are way too small to see, but they're there. So both inside and outside the balloon, there are many molecules of air moving around and taking up space. But you know what's fun about molecules? When they heat up, they start to move differently. That's right. When something gets warm, the molecules that it's made of start to move around faster, bouncing around and spreading out. And that's the important part. They spread out. So let's think about how that would happen in a hot air balloon. When the balloon is on the ground and ready to go, it has some air inside it. And that air is the same temperature as the air outside of the balloon. So the air molecules are all moving around at the same speed and are just as far apart from each other, both inside and outside of the balloon. But then the balloon pilot makes the air inside the hot air balloon hot. You see, these balloons don't have engines like airplanes do. They have big heaters that send flames up into the balloon. So when the pilot turns on the flames, it heats up the air inside it. That makes the molecules of air start bouncing around inside, and they start to get further and further apart from each other. As these molecules spread out, they start to fill up the balloon even more. And when those molecules of air inside the balloon start to take up more space, we say that the air becomes less dense. Soon, the air inside the balloon becomes less dense than the air outside. Now, maybe you remember when we talked about why some things float and other things sink. We learned that things that are less dense than water will float to the top, while things that are more dense will sink. And the same is true with our balloon. The hot air inside the balloon is less dense than the cool air outside, so the balloon can float up. In fact, warm air always floats up. Have you ever noticed that in the winter, when you have the heater on, the downstairs of your house is usually a lot cooler than the upstairs? That's because the warm air in your house is rising to the top. So in a hot air balloon, the hot, less dense air inside the balloon rises up on top of the cooler, denser air outside, and that makes the balloon rise. Now, how does the balloon get back down? Well, the pilot opens a flap at the top of the balloon that lets the hot air out. As the balloon fills with cooler, denser air, it begins to sink gently back down to the ground. It may be hard to believe that something so big can be carried by little molecules we can't even see, but that's what makes hot air balloons and science so amazing. Do you have a question about anything else that floats or flies? Do you want to know how something works? Then ask a grown-up for help and leave us a comment below or send us an email to kids@thescishow.com. We'll see you next time.
Okay. All right, so I hope that was a little helpful for you there. What happens when air inside the balloon is heated? Well, when anything gets heated, its molecules will spread apart, right? And that, of course, makes it less dense. Why do they have to be so big? Well, if you think about it, in order to carry that kind of weight, a couple people in the big basket, it's got to have a lot of air because that's a big force it has to lift up. And how do you make a hot air balloon land? Well, instead of putting hot air in, right, you gotta let the hot air out, and of course that allows cold air to come in and it becomes denser. All right, so make sure you pencil in some answers there. All right, how does temperature affect density? At this point, I think we know, without a doubt, temperature, if you increase it, it's going to decrease the density. All right, as temperature increases, the density will decrease. All right, as temperature increases, this will, of course, will make the volume increase, right? When you heat things up, they expand. And that, of course, makes them less dense. The example, the rising hot air balloon. Okay. Now going the other way, just switch it around, right? As temperature decreases, density will increase. All right. That, of course, will make your volume decrease. All right. So I hope that made sense to you. Okay. How about pressure? Well, you guys have all had a snowball fight. You really want to make a snowball, you got to pack that snow in there. You put a lot of pressure on it, and it makes it denser and denser, and then you can really throw that snowball far and with accuracy. Well, the same thing works with most other objects. This is called a Cartesian diver. When you squeeze the sides, it actually makes the object on the inside a little denser, and of course it sinks. Okay? Pressure and density, right? As pressure increases, well, so does the density, right? They'll both increase. However, your volume is going to get smaller. Your volume will decrease. All right. Opposite of that, of course, if you let pressure off, boom, you allow it to expand like the hot air balloon, you will become less dense. So as pressure decreases, so does the density. And of course, the volume will expand. It will increase. Okay? All right. In which state of matter are objects the most dense? There is an exception to this, but it did say, well, it should say most objects. Anyways, usually gases are the least dense, right? They're the most spread out. And then liquids, the molecules get closer, so it's denser. And then as a solid, most things, of course, are their densest. But there is one exception to that. We'll chat about that. You probably know it. It's the reason you don't put water in a glass in your freezer, right? Because when water becomes a solid, its molecules spread out at the last second, causing it to become less dense. And that's why ice floats and will crack, of course, any glass you put in your fridge. All right? Most dense, least dense, and of course, in the middle there, most, underline most objects become denser as the state of matter goes from gas to liquid to solid. Okay, the exception, there it is. The exception is water. Water is the weirdo. It is densest as a liquid. In fact, it's densest at 4 degrees, right? There's a strange random number. But at 4 degrees, it's at its densest point. And then as it goes down, 3, 2, 1, 0, and freezes, it expands and becomes ice. All right, and there it is, folks. Why does solid ice float? Well, it's densest at 4. Its density as a liquid is 1.0, but not as ice. You decrease the temperature, and of course, the water will freeze. It will expand, and it'll drop its density to about a 0.5. So that's why ice floats, because it's less dense than a 1, which is the water. Okay? Notice, however, the ice kind of floats just at the surface. It's not all the way up there, right? It's not like a very, very low density piece of balsa wood, let's say, where that floats very high on the surface. Ice just kind of lingers in there. And that's why the Titanic didn't see that iceberg till the last minute, right? They would sit pretty low in the water. And even the tip that you did see, well, what's below is much bigger. So even, I'm sure you saw that movie, even though they tried to steer away from it, there's still so much more ice below the surface that ended up cutting a hole in that ship. Okay? So anyway, to sum it all up, how does temperature and pressure affect density at this point? Hopefully you got this down. So say to yourself, as temperature does this, pressure does this, right? Use an as statement and make sure you get it in there. We'll discuss those in a minute. Why does ice float? You tell me. What's going on there? Tell me about the molecules. Tell me, about being compacted or expansion and whatnot. Okay, and when is water the most dense? Remember what temperature that is. If you got to look back, go ahead and look back All right? And we'll discuss these in a moment. All right? See you back at the meet.